Quartz is the raw material used to make computer chips. It's first crushed, ground and purified in a high-temperature furnace until it becomes monocrystalline silicon with a purity of 99.99%. This silicon crystal is then sliced into 300mm wafers, each just 0.75mm thick. A barcode is sprayed on the back, and a small notch is cut from machines to recognize orientation. These wafers are extremely fragile. A single chip can shatter with the lightest bump. Each wafer costs about $100, but when processed into CPUs, its value can soar to $100,000, making it more than 10 times pricier than gold. However, not every chip that rolls off the line is perfect. Each grid on the wafer must undergo rigorous testing. Defective grids often differ only in performance, so testing software marks each one, classifies them by yield rate, and assigns performance tiers. That's how Intel defines its lineup: i9, i7, i5, and i3 processors, with lower price models having more defective or disabled cores. Inside a desktop CPU lies what we call a chip, one integrated circuit containing 24 computing cores, a memory controller, and a built-in GPU. If you zoom in on one core, you'll see 44,000 transistors, which represent only 0.0017% of the total transistor count. Magnified times 100,000, you can see countless metal wiring layers stacked above transistors, insulated by thin films. Each chip contains hundreds of kilometers of wiring, 5 metal layers per transistor, all interconnected by vias, stacked layer by layer into a single CPU. A 300mm silicon wafer can produce 230 CPU chips, or about 900 memory chips, since memory dies are smaller.